how can India, China's getting there, right? China's got several planes that they made, both in commercial and defense markets. But how could we potentially do that in aerospace and defense in India? And that was my whole purpose over the past 5, 6 years. Has been my life mission. I've been training for that. And there was a point in time when I figured being in the company with RTX, it's going to be very hard. So I said, okay, let me jump out of the company. My execs at the RTX helped me jump out of the company. They gave me an early exit. And here I am. I just launched my company yesterday, and it's called AeroDef Nexus. Like Manoj was saying, it's very fluid. It's just one man army, and that's who I was in my previous job, right? So sometimes people say, what a one person could do. Let's go back to Gandhi. What did he do? Right? He created this movement where India became free. Let's go back to Sardar Patel, right? The gentleman brought several thousand kings and queens together. What did Mr. Modi do? What did Jawaharlal Nehru do? And we can go on and talk about it. So call me a madman, call me whatever I am, but that's who I am. I'm trying to develop this market. And in the process, I went to Wharton University, did my global C-suite program, and which actually broadened my worldview, right? So today I'm focused on India, but I'm going to scale this in India. I'm going to take it to all over the world. There are multiple lines of businesses that I'm thinking about launching. Some of them are just for survival, but eventually, what I want to do is build planes out of India, and four categories of planes, right? Number one is fighters. Now, Dr. Kota is a very good friend. He's the father of LCA Tejas, and he built those planes, right? And it took him 30 years to build those planes. Now, how can we make the next gen fighter, which is the advanced medium combat aircraft, how can we make it faster? How can we make it cheaper? How can we export it? So I'm working with Ministry of Defense and ADA to see how we could do it. And now I don't care anymore whether it's Collins, RTS. It's just about making that plane happen. How do we make it happen? Mr. Jadhav at ADA is a very good, very senior colleague. And when he was an AL director, I happened to host him at Collins Aerospace. So I'm working with those folks. The second one is the next gen helicopter program. And again, early stages, it's called the Indian Multi-Role Helicopter Program, 13-ton category. There are 12,000 of them in service all over the world. It's essentially to replace Mi-17s, right? Mi-17s is the aging Russian fleet of the helicopters, and then they need to be replaced. So HAL has had this on a drawing board for a long time. For HAL, now it's now or never. And there's a program director who's appointed for the program. Chairman personally is watching this program. And that's something that we're working on. And the third one, and that's even more strategic, is what China did was they started small. They built a very small plane called ARJ, right? And then they built the C919. 919 flew in Singapore Air Show a few years ago. There's lots of Chinese airlines who place orders, and now it's starting to expand to Southeast Asia. Eventually, I feel China will be a threat to Airbus and Boeing. Can India do it? And how do we do it? Is the next piece that I'm trying to figure. And again, there are multiple puts and takes. I'll be meeting the minister tomorrow in Delhi, and I'll run it by him and see what we could do. The fourth piece is the future of WASP, right? And again, we're working with several startups. And my goal is to bring startups, PSUs, bring everyone who wants to help together, bring the PE firms, bring the consulting firms, bring everyone together to really make this movement happen. And if it is not now, it would never happen. And I think timing is right. If you look at the United States, Mr. Trump's just taken over and Mr. Musk is out there. And I just heard from my wife that Tesla just signed a partnership agreement, isn't it? So what could be a better time than now for a US-India relationship to strengthen? We will also potentially have French in the mix, we'll have others in the mix, whomsoever wants to come and help India grow its aerospace and defense ecosystem. That's been my life mission. And that's what I'm going behind. I don't know if I would be successful or not, but I really need all your, help and, recommendations, and blessings from all of you. The next piece that I wanted to talk about is the composite technologies. And this is the business that I spent a lot of time working with. I would say more than a decade. And I'm going to talk from my experiences. I'm not going to talk theory. So Collins Aerospace, there's a business called Aerostructures, based out of San Diego, Chola Vista, right? And this place I call my second home. I still remember the street address of a hotel that I used to stay at, 1747 Pacific Highway, residence in San Diego, right? So that's where I stayed. We worked on several programs together with the teams in San Diego. We worked with folks in Mexicali, right across the border, and we worked with folks in Singapore because they had an MRO and they could build the R&D units. So, and I was based out of India. Our primary job was engineering, primarily design, stress, and eventually we expanded it to operation support, but till date it continues to be mostly engineering in India. And there is some level of expansion that's going on now with regards to sourcing, with regards to machining parts. But now when you talk about composites, composites are the differentiator for the aircraft technologies. And why is that? Because you need them to be lighter, right? You need them to be resistant to, and specifically the nacelle. Nacelle, if you don't know, is a housing around an aircraft engine, right? Just very simply, housing around an aircraft engine. There are 4 or 5 parts of a nacelle. Number one is called inlet, which provides you a laminar flow and gives you a better, aerodynamic performance. Number two is fan cowl. You open it up, and it essentially, you open that app and you do oil cooler or whatever lines that you need to replace. It's for maintenance. And the third piece, which is the most complex piece of equipment, is called thrust reverser. So when an aircraft lands, it's not an FAA requirement. Pilot could potentially land it with a brake, but you have a thrust reverser there, which provides you at least 20-30% reverse thrust. Super complicated piece of an equipment, super expensive as well. And that's where your engine core temperatures are as high as 1500, 1600 F. So now composites, as you know, cannot take more than 250 F, right? Even if you use a BMI, it could probably take a little higher. So what you do is you end up putting a thermal blanket there. So you have, and in fact, at a certain point in time, we were even considering you would put a titanium, structure there. And at the aft of your nacelle is essentially exhaust system, which is typically Inco or titanium because of high temperatures. And you've got lots of EBU taps and so on and so forth. So that's the business I work with. And this business was founded by Fred Rohr, right? Fred Rohr built these structures in World War. And since then, they mastered it. There was a point in time, if I remember correctly, in 1990, this company was about to be shut down. It was going through significant doldrums, and they were selling furniture to survive because they were not winning any new programs that become so heavy. And that's when they brought in, all the experts that implemented TPS in Japan. They brought the lean experts, and in fact, employees there in San Diego bought shares of the company, and they said, "We will not let this be liquidated. We will not let this be gone to a PE firm." And eventually, that company survived. They won the 787 program. 787, by the way, is the best ever aircraft made with composite structures, best technologies ever. The program was delayed significantly because they went all around the world, and there are a lot of images on internet. If you search, you'll find, it was built all over the world. So 787 was one of the latest programs we won, multiple variants. But let me just talk 787 itself. Super complex, and what are the technologies that goes into it? 787 aircraft has dash 8, dash 9, and dash 10, 3 variants, right? And now you look at there was also a GE and Rolls-Royce engine. So there's such an intermix that you need to do. Dash 8, dash 9, dash 10. Every config is slightly different. You have a GE engine, Rolls-Royce engine, and then there was a performance improvement package that was coming in from GE. And there was a pack one, pack A, pack B, pack C that was coming in. It was a very interesting program. Talking about the technologies, typically, as of today, most of the composites are made out of carbon fiber, at least the ones that I used to work with were carbon fibers. And, most of them were made out of autoclaves, and especially the structures that were expensive to do in the US. We actually sourced many of them from Southeast Asia. CTRM used to be one of our largest suppliers, right? We built a plant in China called GAT and Tianjin, and the plant manager there used to be a friend. We also, source quite a bit of, specifically Cascades composites from Nikiso in Japan and Vietnam. We needed women with very little hands. It was all hand laid up, right? And those were the women who did it. Now, we also evaluated back in those days suppliers in India, and Tata was one of the players that we evaluated. This was, I believe, 2008, the year I joined the company, and they were just not ready. And that's when the package went to CTRM. And I think since then, Colin's boss was missed. Since then, Tata's have improved significantly as far as their composite technologies are concerned. And I've been to their plant several times. SRM was a friend, and now the current person, I know her as well. Sri Devi runs the plant. So Tata is a great player. HAL is another player in India which does a lot of this composites work, right? And they build the composite plant. The ACD is a division that they have. Kaneko Kaman, Mr. Sardesai is a friend as well in Goa, and they keep bugging me to bring more composites work. So that's another plant that's out there. And L&T and used to have a plant where personally walked in, and they used to make missile structures, long woven structures, missile structures for ISRO. It was in Baroda. They moved it to Coimbatore, and there was a guy we actually hired from Coimbatore who went on to found another company and another entrepreneur. He's building a company in Coimbatore. So there is Azusta Composites. There is several other smaller composite companies, Van Technologies out of Hyderabad. So composites is not a big challenge, but the problem with the composites, today's composites, is cycle times are super long. Raw materials are not sourced within the India. Special process certifications are not done within the India. So it's a super complex ecosystem. So I think if we were to excel in composites, we'll have to start right from raw materials. And you know what? Torre is one of the suppliers. Hexal is another supplier. And Torre has a plant in Chennai. We figured it, right? Now they do it for automotive grade. Automotive grade composites are chopped fiber, not super complex, not long fiber. So they're able to do it. But if we were to do it for aerospace, I think we'll need to incentivize Torre. We need to incentivize Hexal. We'll need to, get them to do big things in India. Number one. Number two, is special processes certifications. Now we can build composite structure for our own fighters, ISRO. That's fine. But when you have to go to the world, you got to have the well best in class processes. Your plant must look neat and clean. Tata's plant look much better. Many of other PSU plants don't even look good. And by the way, I forgot to mention NAL is another great organization. If you want to do composite research, that's potentially another organization I would go to. They showed me several co-cured structures, and again, NAL director is a good friend of mine. Um, but problem today is we're doing it at a small scale. You just don't have a scale that costs go down, and you can do big things. So if we were to do big things, we'll need raw material source, we'll need special processes qualification, we'll need to also invest in the technologies that are coming in future. Composites is not going to be all these long cycle time technologies, right? And these heavy pieces of equipment where you put in millions of dollars of capex. It's called the autoclave, literally big giant elephant that you invest in. Instead, what's happening, and that's something that Collins was doing, privy to some of that, so I can talk about it. Collins Aerospace went and bought a company in Netherlands, about 10, $12 million acquisition, but a gem of a company, right? A 50 people company, they build the thermoplastic structures. And now what's the beauty of thermoplastic structures? Thermoplastic versus thermoset. The earlier versions of thermoset, this is thermoplastic. And you can build it really quickly in a matter of minutes. You can almost stamp it like you stamp a sheet metal part, right? Now there's some pre-work to it, but that's beautiful. Now, that's just for flat structures. There were a couple of other technologies my friends in US were working on. And in fact, there's a pilot line that Collins Aerospace set up in a facility called Riverside, right? And that's where they're building the entire fan cowl for an A220 nacelle. right? The fan call demonstrator is ready. It goes to every air show. It went to JEC Paris a few years ago. It goes to every damn air show. So that's where I think the future is going to be. Now, I've talked to several people on thermoplastic topic. NAL is invested in thermoplastic press, but that's just stem farming. You need to do welding, and now just like sheet metal welding, you could do welding for composite parts. And there are different techniques. It's not even called welding; it's called joining. There's a significant amount of dollars that you need to invest in allowables program. Allowables is a big, big deal, right? There's material science that needs to happen. And that's one area, but the other area is, and I think this is out there, ceramic matrix composites, CMC for high temp. You also got carbon brakes. That's where composites are used. You also have 3D printing for composites that's happening, and I don't know, Akshita, if you do any 3D printing for composites. I have seen one facility in Bangalore. I've not seen many which does 3D printing for composites. And then there is a biodegradable. Again, the good thing about thermoplastic is, it's recyclable. I can remold it in whatever shape I want. And that's a huge advantage in an ESG world. That's been my time. I hope it was worthwhile and you learned something. If there is anything else that you would want to learn about composites, just hit me up on LinkedIn and I'll be happy to help you.